Hi everyone. In this video I have this question to work on. It's based on applications of what we call implicit differentiation. So we have the question here where to determine the equation of a tangent to the circle whose equation is this one at x equals 1 for y being negative. Now how do we approach this? Well, equation of a tangent involves two things. One, a point on the tangent because the tangent is a straight line. We also need to work out gradient of this tangent. That's where implicit differentiation comes in. So let's first of all determine the point on this tangent. Right, so this is page 1. What we're taught is that the equation of a circle is x squared plus 2x plus y squared minus 6y minus 10 is equal to 0. And we are told we're interested in at x equals 1, and we're told for y being negative. So when x is 1, what is the value of y? So we are to substitute where there's x, we put 1 in that space and then solve the equation for y. So we're going to say, therefore, when x equals 1, what we have is we have 1 squared plus 2 times 1 plus y squared minus 6y minus 10 is equal to 0. Remember, x equals 1. So this is 1 plus 2 plus y squared minus 6y minus 10 is equal to 0. And you'll agree with me that this is y squared minus 6y and then plus 3 minus 10. Remember, that's 3 is equal to 0. So this simplifies to y squared minus 6y minus 7 is equal to 0. Quadratic factorization, factorizing this one here, if you will recall, I will try and remind you here. Quadratic factorization, what we do is we take the y squared and minus 7 multiply them, so you're gonna get minus 7y squared. That is called the product, and we're looking for the sum. The sum is the middle term, which is minus 6y. So we're looking for two terms whose product is minus 7y squared and whose sum is minus 6y. Now how we approach it is by saying, what are the factors of 7? 1 is one of them. So 1 into 7, the answer is 7. Now remember, there's a minus sign here, which means the signs of these two numbers must be different. So I can have a plus here, a minus there, or a minus 1, a plus 7. And obviously you are going to have y there, y there, y there, y there, because to multiply the two, you must get that. Adding these two up, you find 6, exactly minus 6y, which means these are the two factors we're looking for. So these two factors must come in the center. We're getting rid of minus 6y, replace it by these two, and then carry on with factorization as follows. So we're saying this is the same as, if I move this one down, it's the same as y squared minus, remember, we have these two terms, plus 1y minus 7y, or you can simply say plus y, plus, I'm going to keep 1, and then minus 7y, and then minus 7 is equal to 0. Group the terms. The common factor on the first two is y, take it out. Y into y squared y into 1y, obviously you can see is 1. And then the common factor on the second part is minus 7 in there. Minus 7 into minus 7y is y. Minus 7 into minus 7 is 1, is equal to 0. Again, you can see that the common factor here is y plus 1. So we are now saying y plus 1 as our common factor. The other bracket must contain what you have there, y minus 7 is equal to 0. Solving this equation now, we have the following solution, taking us to page 2. So now we are saying what we have now is the following. When two numbers multiplied give you 0, either one is 0 or both are equal to 0, or the other is 0. So therefore, either y plus 1 is equal to 0, or y minus 7 is equal to 0. This gives you y equals minus 1 or y is equal to 7. But we are told at the beginning in the question, they are saying that y must be negative, as you can see, and therefore this is not applicable. Our solution, therefore, y is equal to minus 1 is what we're going to take. So therefore we have a point here. Therefore the point on the tangent is, remember, x is 1, y is minus 1. This is the point. What we need now is gradient. That's where implicit differentiation comes in. Remember, gradient of a tangent is actually the derivative of the function, derivative of y with respect to x. Differentiation, what is differentiation? The process of finding or determining the gradient of a tangent to a given curve. So now we're interested in m tangent, if you like, gradient of a tangent. This is going to be equal to dy dx. Now, what are we given? We're given equation of a circle, x squared plus 2x plus y squared minus 6y minus 10 is equal to 0. We're going to differentiate this equation implicitly with respect to x as follows. So we are basically saying, therefore, derivative with respect to x of the left hand side, which is x squared plus 2x plus y squared minus 6y minus 10, must be the same as derivative with respect to x of the right hand side, which is basically 0, and we know 0 is a constant. Taking us to page 3. So we're now saying on the left hand side, so this is page 3. On the left hand side, derivative of x squared with respect to x is 2x. Derivative of 2x with respect to x is 2. And then we have y squared. We differentiate y squared implicitly. So first 2y using power rule. And then we have dy dx. Remember, dy dx. And then this part here, we just have minus 6. And then dy dx. Derivative of minus 10 is 0 because minus 10 is a constant. And this is equal to derivative of 0 is 0 because 0 is a constant. There you have it. So now we have to solve for dy dx, which is gradient over tangent. How does it go? Well, I'm going to keep these two on the left and factorize. You can see the common factor is dy dx. So we have 2y minus 6 times dy dx is equal to, take these two terms to the other side. You can have minus 2x minus 2. And I'm going to divide by this both sides to solve for dy dx. So this implies dy dx is equal to minus, if you like, take minus 2 out, open brackets, x plus 1. When you factorize this part, you get this all over this part here, which is 2y minus 6, which I'm going to factorize as well. So what are we having? We're having dy dx is equal to minus 2x plus 1. Denominator, take minus 2 out as a common factor. Minus 2 into 2y is minus y. Minus 2 into minus 6 is positive 3. This cancel. You can rewrite that to x plus 1 all over 3 minus y. So this is gradient of a tangent at any point x comma y. But we've been given a point. So what is that point? Here is the point. 1, x is 1, y is minus 1. So I must substitute the two values simultaneously here to determine the value of m, which is gradient of a tangent. So now I'm going to say now here, therefore, at 1 comma minus 1, taking me to the next page here, I can use this part. I don't want to use it. Space there is not enough. Let's go to page 4 to just finish this off now. So what I'm going to say now is dy dx will be equal to substitution. So 1 plus 1. Remember, we're putting 1 in there and minus 1 here. All over 3 minus 1. This is 2 over 4, and that's half. So we're saying, therefore, m tangent is actually equal to dy dx evaluated at x equals 1, y equals minus 1, which is what we've done there. And what is this equal to? Well, this is exactly equal to 1 over 2. That's our gradient. So now we're going to have to go to what is known as point slope formula. So point slope formula says y minus y1 is equal to m x minus x1. Now, which one is our y1? Well, we're gonna call this point, this is gonna be called our x1, and we're gonna call that one our y1. And we substitute the two with our gradient into this equation here, and then we're done. So to finish this off, this implies y minus, what is y1? Minus 1 is equal to, what is m? It's m tangent, 1 over 2. And then we have x minus, what is x1? x1 is 1, as you can see there, 1. Right, simplifying this, we have y plus 1 is equal to 1 over 2 x minus 1 over 2, distribute 1 over 2, and then subtract 1 from both sides. Y will be equal to 1 over 2 x minus 1 over 2 minus 1. And our final solution in this question here is y is equal to 1 over 2 x minus 3 over 2. That is minus 3 over 2. So this is the solution to our question, which is this one here. Determining the equation of a tangent to the circle whose equation is this at x equals 1 for y being negative, y less than 0. And this is our final solution. Tell me what you think about this question. How would you have approached it? Do not forget our implicit differentiation over here. How we differentiated this equation here. How we differentiated this equation coming from here, going down there. Derivative of that with respect to x, to there, we had to use implicit differentiation. First, differentiate y squared to y, and then divide dx, because we're differentiating with respect to x. And then here, minus 6 is a constant, you just have to divide x. Derivative of 10 is 0, it's a constant, and at the end there, derivative of 0 is also 0 because it's a constant. And then carry on with the calculations arriving at this as our final solution. Of course, not forgetting the fact that we had to use what we call the point slope formula here. All right, I'll see you in the next one.